Okay, this is number 10 from our review. What number 10 is asking us to do is solve a rational inequality. It is x plus 1 over x minus 4 is less than or equal to 3. So the first thing that we're going to do here is we're going to go ahead and solve it. That's going to give us one of our critical values. So we're going to have a couple different critical values, and those critical values are going to help us determine our intervals. So our first step will be to solve. So we solve this the same way that we would solve an equation with a fraction in it. And so we're going to multiply both sides by our denominator in order to solve. So we're going to multiply by x minus 4 over 1. Okay, and when we multiply x minus 4 over 1, on the left-hand side, we are left with just x plus 1 is less than or equal to, and on the right side, we have to distribute that 3. So it's important to remember to distribute the 3. So 3 times x is 3x, and 3 times negative 4 is negative 12. Okay, so now I encourage you to move your variables to the left. That is going to end up giving us a negative variable on the left. So remember, when we're doing inequalities, we have to reverse the inequality sign when we multiply or divide by a negative number. So that is something that we're going to have to do in this one, but I still think it's a good idea to move your variables to the left. So we're going to subtract 3x from both sides, and when we do that, we're left with negative 2x plus 1 is less than or equal to negative 12. So here, in isolating our variable, we're going to subtract 1 from both sides. So I have negative x is less than or equal to negative 13. Here is where we have to focus on dividing both sides by negative 2. And because we're dividing by a negative, that is when we reverse our inequality. So we have x is greater than or equal to 13 over 2. And that is one of those things that we have to do when we divide both sides by a negative. So what we have here is we have our first critical value. So our first critical value that we're going to focus on is 13 over 2. The way that we determine our next critical value is we set our denominator equal to 0. So we have x minus 4. We cannot have 0 in the denominator, and when my x value is equal to positive 4, that gives me an undefined inequality. So x cannot be equal to 4. So our second critical value is 4. So what we have is we have 13 over 2, and then we have positive 4 as our critical values. What I'm going to do now is I'm going to take my inequality and I am going to have 0 on one side. Having 0 on one side helps us when we do our test points. So what I'm going to do is I'm going to subtract 3 from both sides, and I'm going to have the whole thing less than or equal to 0, and that will help us with our test points. So I'm going to create our x-axis, and I'm going to identify our critical values. Notice both of our critical values are positive, so we don't have to worry about any negative values. So here I'm creating my x-axis 0. Okay, our first critical value is a whole number at 4. So there's my dot there for 4. 13 over 2. That is actually 6.5. 13 over 2 is 6.5. So my x-axis needs to be a little bit longer. And so we're actually going up to 7 there. So here is 6.5. So that's another one of my critical values. So we are going to create our intervals. So we're going to have 3 intervals, and we're going to have 3 test points. And then we will determine if those test points are true or if they are false. So our first interval is going to be negative infinity all the way up to our first critical value, which is positive 4. Then our next interval is going to be in between positive 4 and 13 over 2. And then our last value is going to be 13 over 2 to infinity. And we are going to create test points in each one of those. Now our first interval is negative infinity to 4. So we can use my very favorite number 0 for that first test point. The next interval is 4 to 13 over 2. So that is 4 to 6.5. So the test point that we're going to use here is positive 5. Then our last interval is 13 over 2 to infinity. So we can use 7 as our test point. Now, to do our test point, we are trying to determine if the statement is true or false. So I am going to go back to this inequality statement, and I'm going to plug 0 in for x. That's my first test point. So when I plug 0 in for x, I get 0 plus 1 over 0 minus 4. So that is negative 1/4 minus 3. What that's going to do is that's going to give me a negative number. It's actually going to give me negative 3 1/4. And negative 3 1/4 is less than 0. So this is going to give me a true statement. So in a minute, that will determine that our negative infinity to 4 is one of our parts of our solution. So that's what that true means. Now, our next test point is 5. So that is going to give me 5 plus 1, which is 6, over 5 minus 4, which is 1. So I end up with 6 over 1. 6 over 1 minus 3 is positive 3. Positive 3 is not less than or equal to 0. So that gives me a false statement. Okay, so that makes it false. So that means that interval is not going to be part of my solution. Our next test point is 7 plus 1, which gives me 8, over 7 minus 4, which gives me 3. So I have 7 over 3 minus 3. So we're going to have to deal with some fractions there. So I'm going to write this out. 7 over 3 minus 3. So I'm going to make that 9 over 3. And the reason that I've made it 9 over 3 is 3 over 1 becomes 9 over 3 when I have a common denominator of 3. So 7 over 3 minus 9 over 3, I want to know if that is less than 0. 7 over 3 minus 9 over 3 does give me negative 2/3, and negative 2/3 is less than or equal to 0. So that gives me a true statement. So now what I'm looking at is I'm looking at my intervals. Now this interval that gave me a false statement, I am going to mark out completely because that is not one that I'm going to use. So the only intervals that I'm focused on are negative infinity to 4 and 13 over 2 to infinity. But I have to decide what is going to give me, what do I need to include? Where do I need to include those brackets? So if I look back at my original problem, you'll notice that my original problem is less than or equal to. So that means I do have to have some brackets. Now the critical values that I'm looking at are 13 over 2 and 4. 13 over 2 was our solution. So 13 over 2, it is okay to use 13 over 2. So whenever I see 13 over 2, I'm going to have a bracket there because 13 over 2 can be included. However, when I look at 4, what happens when I include 4 as part of my solution? If I were to include 4 as part of my solution, we go back and we look at our denominator in our original problem. If I put 4 in there, that's going to give me something undefined. and I cannot have anything undefined. I cannot have 0 in my denominator. So when I write my interval negative infinity to positive 4, I have to use a parenthesis at positive 4 because 4 cannot be included. If I were to use 4, it would be undefined, so I can't. So I'm going to have negative infinity up to 4, but not including 4. That's why I have that parentheses. Then I'm going to have a union, and we've already discussed that 13 over 2 is okay. 13 over 2 does not make anything undefined, and because of that, or equal to, 13 over 2 is included in my solution. So I'm going to have bracket where my 13 over 2 is, and then I'm going to take that all the way to infinity. So my solution to this is negative infinity to positive 4 with a parentheses there, union bracket 13 over 2, because that's included, all the way to infinity. And that is the solution to this inequality.